second case study from Luiz Monteiro da Fonseca from the Brazilian Hydrographic Center in Niterói. And this talk will be about applications of operational oceanography in protecting human lives and the marine environment. Luiz, floor is yours.
Thank you, Alberto. Okay. Hello, everybody. I'm Luiz Cláudio, Direct Captain of the Brazilian Navy. I'm also the coordinator of the REMO project that I will explain during this section. I work at the Navy Hydrographic Center, which operates the Marine Meteorological Service. Today, the goal of my presentation is to illustrate through some real case the importance of the operational oceanographic forecast service for safeguard of human life and protection of the marine environment. And to accomplish this, I will go through these topics. I will do a brief review of what is the REMO project. Then I'll talk about our oil spill model, presenting two real cases. Next, I'll present the Navy SAR model and a real case that happened last year and make some final considerations. Well, HEMO stands for Oceanographic Observation and Modeling Network. It's a great partnership between the Navy, the Brazilian oil company Petrobras, and universities. Nowadays, the federal universities of Bahia and Rio de Janeiro are still in the project. HEMO was responsible for the first operational oceanographic model in Brazil, and it's an important support to the Marine Meteorological Service. I usually say that the REMO is an example of a successful partnership because both Petrobras and the Navy, they can invest what they can. Petrobras with the funds, the Navy invests with its operational infrastructure and human resource, and both institutions obtain benefits for its main activities. In Petrobras, to support the offshore activities, and the Navy, the safety of the navigation and support the naval power. Most of our products are available on this website that we call the Marine Environment Forecast. And in this website, and we updated it daily. And in the next year, we intend to put our daily run for our oceanographic of our oceanographic model available to download. Well, going through the oil spill model, in the last 3.5 years, the coupled model for oil spill prediction, the CEMOP, which was developed by these two researchers, Luciana Tessarolo and Fernando Barreto, was incorporated in REMO in order to be the Navy operational oil spill model. The model is based on 3 different modules: the plume dynamics, the advection diffusion, and surface. It can run both forward and backward in time and be forced by different atmospheric and oceanographic models. The main code is Fortran, and the post-processing is mainly done in Python. Within our project, we are developing a user-friendly interface for the CMOP to run it, trying to put some to run it in and trying to put some configurations in default mode for the basic users, and allowing also some modifications for the advanced ones. In this image is an example of what will be this interface. And here is what will be the image of an example after their model finished the run. An example of an oil spill product is indicated here, where we can see the stain is likely to drift with where is it likely to drift, and the thickness and mass balance. And in the bottom right here is the mass balance of the oil stain. It's important to emphasize that we intend, after our model is ready, to put it to offer to download for any user who wants to run. The first case that I will talk about is about a leak that was identified in south of Cabo Frio Peninsula, which is an important tourist region here in Rio de Janeiro province. The Maritime Authority was concerned and asked to predict where this stain would go and drift, to be prepared to carry out the necessary containing measures. So here we can see two images, one using the CMOP and the other one using an open drift that is also an open model developed by Norwegian. And we can see the comparison between these two models after 20 days forward. Both drift to the same approximate direction. But when we compare the mass balance, we see a considerable difference. After 20 days of operation, the open drift indicates much less oil on surface than CMOP, which in this case was more accurate. In the second case, an oil stain was identified, and it was necessary to clarify where it came from. To accomplish this, it was used the CMOP in the reverse mode. The current and data wind was from our oceanographic model and from GFS. And as it was available, the shapefile of the stain, we introduced the shapefile in this model. This particularly of the CMOP to use the shapefile is very useful, and it's especially in case of kinds of case like this that we want to know where the stain came from. So we identified in this image, you can see what the CMOP tried to model where the stain came from, and it was quite accurate on the origin of this stain. And with this understanding, the measures to contain and mitigate the environmental impact could be planned and taken. The other case that I will talk about is from the Navy SAR model, the SPAD-SAR. SPAD-SAR stands for Planning and Decision Support System in Search and Rescue Operations. It's a system developed to the Brazilian Navy and used in its own operations. The goal is to predict the trajectory of objects drift at sea, both in forward and backward in time. It uses environmental model information to improve the quality of the forecast and was developed to speed up the quality of the forecast and the planning and monitoring SAR operation. Based on the information about the accident, the system selects what rescue coordination centers to activate and the best resource available to execute the search. Of course, one of the most important things to success for the operations is the accuracy of the environmental conditions. On the left, you can see the rescue operation centers distributed along the Brazilian territory. And on the right, it's a bar graph that indicates the number of accidents reported in blue and saved lives in red over the last 5 years. The case that I will present happened on June of the last year. It was about a fishing boat that sank in Santa Catarina's, near Santa Catarina's shore. This case, despite of the weather forecast and high seas warning issued by the Brazilian Navy, a shipping boat, the Safety Safe, left with 8 people on board to direction of 200 kilometers from Santa Catarina coast. On June 16th, the boat issued a distress call and sank, initiating the search and rescue operation. That was the last known position, and when the Navy was activated, he established a search and rescue operation, and in this image, you can see the pattern of search, and the colors stands for the most probability of detection area that it could be drift the survivors and of this wreckage. That was the search and area calculated by the SPOD-SAR model. And after some hours, the wreckage was sighted at the night of the next day, but without any signs of any survivors until that time. Then, after about 5 hours, and at the beginning of the day after, 2 days after the wreckage, it was found a life rescued with 5 people on board. And this is the image of one of our Navy vessels rescuing this life raft. These people remain adrift for over 30 hours on this life raft. At the same day, but at the night, it was found a 6th crew member floating after 50 hours of after the wreckage. And here you can see the rescue carried out by a Navy helicopter that spotted the crew member and had been floating for almost 50 hours. So I believe it's clear the importance of the safety of navigation for any coastal states. Once we all know more than 9% of all road commerce is through merchant ships. So there are no doubts within the maritime community regarding the importance of protecting the human life and sea and the marine environment. This directly impacts the freight costs and therefore the final price of products. In this context, the accuracy of ocean modeling products is quite relevant, not only because of its use in object of oil drift prediction model or at sea or uh, oil drift or object drift model at sea, but mainly because the countless lives saved due to severe weather warnings, lives that uh, navigators who are warning and don't want to succeed because of this or can deviate from this course. In this context, I truly believe that any coastal state that wishes to move towards a development or seek greater relevance in international commerce have to have a reliable oceanographic forecast service. And I, I really believe that in that case, this initiative of the Ocean Project GCC is the best way that we can establish oceanographic forecast service in countries that are difficult or have his own difficulties to establish it from themselves.